Hello everyone. Welcome to SD-WAN Zero to Hero training course. This course will be 30 hours long and I will be your trainer in this particular course. I have partnership with Graphy, which is again a partner of Unacademy. And what I have done that this particular course, this 30 hours Zero to Hero course, I have uploaded to Graphy website. You can get the link below in the description area, and you can go and enroll for this particular course. Now, once you go and enroll this course, obviously, whenever we are watching any online content, what we are looking for, all these online contents will not provide you the lab. But if you go and enroll for this particular course, then you will get two types of lab. One is the EVE-NG file I will provide, where you have full-fledged SD-WAN. Obviously, there is some hardware requirement for this, that you should have 64 GB of RAM, some 8-core processor, etc. Means if you have some server with you, you can easily go and spin up, or if you have some PC, some desktop or laptop with these configurations, these hardware requirements, you can go and spin up this offline lab. So you can see that offering with this course is, first of all, the 30 hours training video provided by me. Then you will get the lab, offline lab. Then I will go and provide you the 700-page lab guide or lab document. Why? Because once you watch the video, obviously you want to do hands-on practice. Now for hands-on practice, you need some step-by-step guide that you can follow and perform the task. Then you will feel confident that whatever you watched in the video, you're aligned with that or not. Means you should have that. You will gain the experience only after you will perform the lab, right? And then I'm going to provide you this particular lab supported. So this is the guide, and then there is a lab. So I'm going to provide you cloud hosted lab for 1 month. Once you go and enroll, and then you have to send email to me. So what you can do that you have the lab and you have the lab guide. You can go and perform all the tasks. Now for basic, just to kick off, basic startup videos, you can go and use this EVE-NG file, and later on for advanced things such as SD-WAN security, cloud integration, T-Lock extension, those type of lab, those type of, you can say the real-time or production-oriented or enterprise-oriented labs, you can go and perform in these places, in this place. Right. So I am very excited to give you such an offer. You have to go check the description box below, go and enroll this particular course. And in that particular course, not only you will get all these information, but obviously there is one community page. If you have any doubt, you can post your questions there, and I will go and answer for all your questions. Whatever questions you will ask, I will go and answer in that community page. That is one of the hard work I'm doing just to build the community as well related to SD-WAN. So if someone will go and join that particular community, that particular course and community, he will get all those information related to interview questions, related to troubleshooting, related to a very good understanding, obviously related to Cisco SD-WAN Viptela. All right, so please go and enroll, and I will see you there. Thanks for joining. We are inside day number 23, and today we are going to discuss about SD-WAN security theory. Later in our big lab, we will go and perform the lab task related to these security parameters that we have in the SD-WAN. Why we want SD-WAN security? What are the options we have? What we can do to cut down the cost? So the whole idea we have related to evolution of SD-WAN, directly or indirectly, it is to reduce the cost, intelligently utilize the bandwidth that we have, In general, if you see the old WAN, you will find that one of the link is heavily utilized and other links are not that much utilized. If any of the link is failing, then we are putting the static route and bringing up the other circuits and all. That is not the case here with our SD-WAN strategy. But when we are using the internet circuits as our transport, so then we are exposing the risk. Now we'll go and see that what type of risk we have and how with the Cisco SD-WAN security features we can mitigate those risks. So let's go and check the security features that we have in the SD-WAN. First of all, we'll go and see that what type of threats we have. Obviously, the agenda is to learn all the security features. I will come to that part. But one thing we know at this point that none of the network is 100% secure. There may be different type of vulnerabilities, bug, configuration issue, some security holes, some loose point from where any type of attack can happen. And if you read the journals and other, will find that 80% of threat is due to internal security, like internal threat. Some employee, they are doing something or they don't know that what they are doing, and then they are inviting the attacks or the scripts within the infra. So 80% of time it is at times it is mentioned that it is due to some internal misuse or internal threat or internal bug. 20% of times it is very high level security breach, and for those type of high level security breaches, the hackers, they are doing that exercises, those exercises, they are taking months in that, it took like months or maybe sometimes years to find the loose point within the network. It's not that all the time the network and network devices are the loose point. You'll find that humans are also the loose points. So these hackers, the high level hackers, they are doing some sort of social engineering as well, right? Maybe they will become your friend and they can put you somewhere and all those things, and they will steal the password, they will guess the password, and all those things is part of hacking. If you go and check those courses, you'll find that it's not all the time logging to the computer and creating some viruses and a script and sending. Not all the time. There are so many other way as well that hackers are using to hack the system. Anyways, no one can go and protect with those type of social engineering attacks and all. What we are going to discuss here is mostly that the internal or external threats, right? Now, if I ask you one thing, as per your knowledge, so as I told you that there are two type of threat, internal and external. Now, if I ask you that to protect from, in general, to protect from internal threat, what we are doing, and to protect from external threats, what we are doing, what's the strategy? So suppose this is one of the perimeter where you have the security, and you may have breaches from outside, or you may have breaches inside. So to protect from the outside attacks, generally what we are doing, and to protect from the inside attacks, what we are doing, you know that? Yep. If you want, you can answer.
Repeat it again in your mind.
Yeah. So to protect from outside attacks, what we are doing, and to protect from inside attacks, what we are doing present in the network, what type of a strategy, devices, rules we are applying. Obviously, firewall, right?
Oh yeah, firewall.
Perimeter firewalls, or maybe proxy servers, or maybe umbrella, Cisco umbrella, right? Now, inside what we are doing.
I think inside you would only have like need to know access or something like that. Like only certain people have need to know.
IPS IDS modules. And then we have Cisco Stealth Watch. We are tracking the behavior of network, anomaly in the network and all when the traffic is inside, right? So different strategies are there to protect from outside and inside, and we will see. But this is very normal understanding that obviously you need some gateway devices to protect from outside, and you need some sort of sensor devices to protect within the premises. Sensors, all these IPS IDS sensors, they are sensors, they are detecting the behavior and the not only the behavior of network users of network, but behavior of protocols as well. If HTTPS protocol, they have to behave like A to B, but they are behaving like Z to X, something like that. So they are detecting the signatures, the algorithms, the behavior of protocol as well, these IPS and IDS devices. And that's why they are very much understanding the signatures as well, right? All right, so different type of threats are there: vulnerability, bug, malware, denial of service, botnet. So n number of threats are there. And now why these threats are increasing? Because now we are using this cloud heavily. So our applications now, they are hosted over cloud, and all the time the remote user, you can see here in the diagram that not only the data center, but your remote users directly, they are going to the cloud and accessing the surface. That means that the threat surface is increasing. Suppose if a branch directly using the internet, then at that time the threat surface is more. And we have one slide where you will understand what does it mean by threat surface. Threat surface means how much you are exposed to the internet. Okay, so now you can see the diagram. Everything has been moved to the cloud. That's the goal of this particular diagram it is telling. All right, so let's try to understand this threat surface. And once we understand this threat surface, then we'll go and check that what type of security measures we have. Okay, so this picture, this diagram, we are already familiar. We know that we have the branches, we have the data center, we have the WAN, etc., etc. Now the problem here is this, that we want to provide security at each and every layer. So we want to provide security at the control plane level, at the data plane level, the infrastructure security, and the user level security, right? So control plane security, how we are doing that? We know that we have very high standard DTLS or TLS connection, that is certificate based secure tunnel, and that's the control plane tunnel. Then we know that for data transfer from one place to other place, the data is moving. So in that case, we have something called IPsec tunnels in between that, and we are using high encryptions and other hashing and other methods to secure that data tunnel as well. So in that case, we have security in terms of the control plane and data plane. Then we are providing security to the devices as well. Now these devices, VEdge and CEdge devices, later in these slides you will find that we have something called TPM chip, Trusted Platform Module, or TAM chip, Trusted Anchor Module in CEdge devices. So if someone will go and steal the hardware as well, is still those devices are something that is hard to boot because they have some sort of security built in related to operating system. We'll see that. And then finally, how we are going to provide the security to the users. So let me show you this in the next slide. You will find that to provide the security, that the user traffic going one place to other place, 4 options are there: integrated, dedicated, service chaining, cloud-based security. This is actually very, very nice slide where you will understand the movement of the traffic plus what security we need and at what site. Nowadays in network, very much is depending upon the planning as well. You have to plan well, you have to design well. So now you can see these 4 options related to providing the security, right? So option number 1 here is this, that nowadays we have option that we can go and enable firewall features within the device. So suppose this is some CS device, some ISR device, I can go use the container feature within the CS device. I can go and put the virtual image, and that particular device will become full-fledged next generation firewall that can provide us VPN security, firewall security, URL filtering, IPS, IDS security, and advanced malware protection. All these 5 features that integrated firewall will provide you. Now, what's the benefit? Now, benefit is this, that think like this, that you don't want to purchase Palo Alto or Checkpoint or any other third party, even Cisco Firepower, any other firewall to secure your perimeter. In other case, or in other words, actually, you are saving the money. So there is one hardware who is doing the SD-WAN work, and then the same hardware is providing you the firewalling capabilities. So obviously, the cost will be less, right? Next approach is this, that you can go and use a dedicated firewall. Now this will be use case when you have data center or when you have higher HQ offices or regional hub, etc. In that case, you can go and use the dedicated firewall, pair of Palo Altos and all to protect. Third case, you can see the service chaining. We have done this method as well, means this lab as well earlier. The service chaining is this, that the user traffic you don't want to send directly to the cloud or the internet. In that case, you can create some sort of data or control policy, redirect the traffic towards the firewall. Maybe that firewall is there in regional hub or some HQ location, and then it will go and use the cloud hosted applications, right? Then we have the 4th model. This also we have discussed earlier, that you can go and use cloud hosted firewall, either Cisco Umbrella or Zscaler or any other cloud hosted firewall to provide the security, right? So these are the features we have related to providing the security. Now let's quickly go and understand the threat surface that we have for these clouds. So let me go to the next slide. Means what is the threat surface in SD-WAN? So now you can see the threat surface. This slide is also very important because according to this slide, we have security features in SD-WAN. So here you can see that if some user simply wants to use the internet, in that case, the threat surface is 100%, means it is 100% exposed to the internet. So what you will do? In that case, you will use all the security capabilities like AppAware firewall, IPS IPD, IPS IDS, intrusion prevention system, intrusion detection systems, the DNS URL filtering, the advanced malware protection, everything. Whatever features we have available in that next generation firewall, in that container based firewall, we can go and utilize it. Why? Because this case we have 100% threat surface. Now, if we have direct cloud access, see, this was DIA. direct internet access. Now we have direct cloud access. So in this case, we have approx 75% threat surface. That's why you can see this pie chart here. So in that case, we can go and use the app-aware routing, firewall, IPS, IDS. We are not using the DNS filtering in this, DNS or URL filtering in this case, because that Zscaler or Cisco Umbrella will provide you that. We are using the direct cloud access. Then third variation you can see here, when the exposure is 50%, right? Guest access. Now guest access is something, guests are not the corporate user or something. They are anyways part of some other VRF. So in that case, we can go and use app-aware firewall. We may create different type of VRF for guest users, and then because guests, they are using some sort of URLs or some sort of websites, so we can go and use this URL filtering, right? Finally, you can see that we are in the case where we are in the compliance traffic. That means this is for corporate user. Corporate user also 25% we have this threat surface. They are using IPsec tunnel. So two different branches, obviously they have IPsec tunnel in between where their traffic is moving. So that's why we have IPsec tunnel. We can go and use firewall. We can go and use VRF in between them. We can go and use IPS IDS. Why? Because IPS IDS we are using for internal traffic. These are the sensors used within the infra. Right. So this particular slide actually very important related to our theoretical discussion related to our Cisco SD-WAN security. You can see that what is the use case and how much security you want to provide in those type of use cases or in those type of users or traffic. So is it not like, again, it's not a good practice that you will use all the security measure in case one, because this is unnecessary. If someone is telling that do not put $100 lock in $10 door, right? You can't put unnecessary security as well, because that will cost money, right? If you are using all the features unnecessary, then it will go and so that particular firewall, you will see that their CPU process, all these will get much more utilized. So as a security professional, we have to assess that how much threat surface is there. According to that, we can go and propose the security. What are the configuration we can do inside SD-WAN? Once I log into the vManage, I will show you that we can go and enable firewalling feature, IPS IDS feature, URL filtering, advanced malware protection features, and some cloud security like embedded, or means we can go and integrate with Cisco Umbrella. So these features, these all features are available. Only thing we have is we have to consider is this, that we have to go and enable the container. Over the container, we have to go and put the virtual image for firewall, or virtual secure image for firewall, and then only it will work. Okay, obviously later on we will see this thing. But yeah, once I go and log into the vManage security dashboard, you can see the firewall, Intrusion, all those features are there, and they will ask you actually. Once you log in, then they will ask you, oh, you have compliance related security, you have guest related security, you have DIA related security, you have direct cloud access security, etc. According to that, you can go and apply the security feature. Now again, same thing. They are the ISR devices, ESR devices. They are providing all sort of security features that again we'll see in the lab. Now these slides we have already discussed earlier, that we have data plane security, we have control plane security. Means SD-WAN itself will offer you good amount of security. We know this thing that SD-WAN, all the controllers, they have different level of security. This thing we know. All the controllers, we have security plus, we have something called vBond that is working as an orchestrator. So everything should first contact to the vBond, get authenticated, and then only they will be part of the fabric. Right. So these things we have already studied in our previous SD-WAN sessions. So I will move on quickly. The next very important topic is device security. As I told you earlier that there are two types of devices. Nowadays, mostly we are using CSR devices, but vEdge and C-Edge. You have vEdge and you have C-Edge. vEdge is using TPM chip. So all the certificates will be preloaded inside this platform chip, and then you have the TAM, Trusted Anchor Module, and this is Trusted Platform Module. Actually, both are very much same, and let me quickly show you the slide so you will understand. TAM, related to TAM, it's like security. So you can see this anchor here, and it is providing the security while the operating system is booting. So that's why we are telling this as a secure boot. Right, and if you want to know a little bit detail about this, so you can see that TAM services and then crypto functions and tamper-proof storage, and then you have the secure UDI. Normally it is like UDI. Now we have SUDI SUDI that will provide you the security related to counterfeits of these hardware. Cisco Trusted Anchor Module, Trusted Platform module, both are used for, one is for vEdge and one is for C-Edge. So the security features we have. Then we have unique device identification. Nowadays it is SUDI, Secure UDI. All these certificates will be loaded here. So what Cisco is doing before sending these hardware to the customer premises, they are putting certificate in that, and then that hardware will reach to the customer. What they have to do simply that at the moment these devices will get plug in to the fabric, the vBond will go and do the authentication, and in the ZTP process or plug and play process, they will go and contact obviously the vBond, the mother vBond, like the parent vBond. From there it will get redirected to the enterprise vBond, and then they will go and trust these certificates, they will authenticate these certificates, and then only that device will become join the fabric. Right. So these steps are there that that is happening actually behind the scene, and in this way Cisco is providing security to their devices, to their hardware. Now this is actually a very important slide, and we are not seeing this because this is by default, these policies are by default set there in the devices, but we can log into the device and we can check. Now in the diagram clearly you will see that you have DTLS connection, right? So the point here is this, that when we are forming such type of control connection, right? And in the below, in the bottom, you can see that there is one other device, unknown source. So there may chance that so many unknown source, they try to establish the control connection with the controllers. This is some sort of DOS attack, right? Suppose if you want to do some DOS attack is simply that your resources are wasted to replying unnecessary request. That is the DOS attack. For example, one server is there which is doing its application services. Somehow if you will go and send 100 ICMP ping from 200 devices, what that server will do? It will start responding for those ICMP packet. You are sending ICMP request, it will send you reply, request, reply, request, reply. like that. So doing its actual application services, what it will do, it will go and start replying you. So to protect from that DOS attack, what is happening, that these devices in their control plane, we are putting some sort of limit that they will go and respond 300 packets per second. That means that request is coming more than this. That means some DOS attack, anyways, they will not entertain. So so the fact here is this, that they will go and entertain 300 requests per second. If we will go and send 5,000 requests per second, that means anyway, they will not respond. Some sort of security is there related to control plane. By default, it's there. If you want, we can do some changes, but it is recommended we should not change it. Right? So now what we have done, we have studied, first of all, that what type of security offers we have from the VES devices or CES devices. CES devices, if we go and install the virtual image over the container, it will work as a full-fledged next generation firewall. It will provide you all sort of security such as firewalling security, IPS IDS security, advanced malware protection security, URL filtering, and then you can go and integrate with the Cisco umbrella. So your perimeter security will also serve. Now there are some features. So now you may think that, okay, if I am using VEdge, and if I am using CEdge, do we have any chart that VEdge will provide this and CEdge will provide this? So VEdge can give you some sort of application filtering like basic firewall feature. It can give you advanced firewall feature. It will not provide you IPS, IDS. It will not provide you that. Then it will not provide you URL filtering. Then it will not provide you it will provide you Cisco umbrella integration. Umbrella you can integrate here and integrate here. So you can see that VEdge and CEdge based security, and that's why customer can choose. Let's suppose in a branch, if you have to redirect the traffic towards the hub location, means in a branch you don't need firewall services, so that site you can go and use VEdge. But suppose in a branch, if you want to use these features, so then you can use CEdge and you can install the firewall over these CEdge, and it will provide you all the security. Right, so it depends again what type of hardware we want to choose in the premises. Right, so let's quickly go and discuss about a little bit more about all these features and offering from Cisco. So I will do one thing. I will quickly go and reach out to the section where we have the firewall and IPS IDS and all next generation advanced security features. All these things we know. We know the data integrity. We know all these things. We know the segmentation. We have done this segmentation as well. And over this segmentation, we have done route leaking as well. So we know all these slides. These slides are just for your information. You can go and have a look on these slides. Now I'm going to start the actual security services that we are using within the SD-WAN. So now you can see that SD-WAN can go and offer you firewall, IPS IDS, URL filtering, malware protection, and Cisco umbrella integration. And this is the dashboard. If I log into the vManage, you will see this type of dashboard. So vManage will ask you that I have inbuilt workflow, which type of user you have, for which type of user you want what type of policies, like that. So we know from our previous initial slide that compliance, that means the threat surface is 25%. Let me write here, compliance means your enterprise user, here threat surface is 25%, guest access, here threat surface is 50%, direct cloud access, threat surface is 75%, direct internet access, threat surface is 100%. And then obviously custom means you want to use this plus this, you want to use this all. So that's the custom policy. You can mix and match. So Cisco is offering you both the things. If you are not sure which type of user, what type of policy you want to use, you can go and use their defined workflow. You can see compliance. Only you can go and enable the firewall and IPS. Guest, firewall and URL filtering. Direct cloud access, most of the thing. Firewall, IPS, malware, and DNS. Direct internet access, you can see application firewall, actually everything. These many security we have because threat surface is 100%. So we want to enable all the features, whatever we have in the SD-WAN, right? So enabling the feature is easy, and later on, obviously, we are going to see all these things in our lab as well. So for example, how the IPS and IDS workflow or the packet flow is there. Now this packet flow is not necessary that we should understand each and everything in this because very much for the TAC. But anyways, we can see here. So the traffic is moving from LAN. Oops, I will explain you that. So traffic is moving from LAN to WAN. Then what is the workflow? Let's see. So here you can see LAN to WAN means from service side to VPN to transport VPN. So in that case, we can see that we have firewall rule, IPS, filtering, AMP, then the N bar, NAT, and then DNS security. But when the traffic is moving from WAN to LAN, so in that case, firewall, IPS, URL, AMP, little bit difference is there. Otherwise, you can see most of the features for the traffic flow from service side to transport VPN to service side, they are the same. Interesting thing here is this, that when I will go and show you the container feature, then you'll find the interesting thing. So let's quickly go and reach out to the container. So all the time I'm telling you one thing, that what we can do, that we can go to the CH, right? So I have my CH. Oops. We can go to the CH and let me go here. Suppose I have my CH. In this CH, I may have different services running. What we can do in this CH is this, that we can go to the container. Suppose this is one of the container, and in that you can go and install virtual image for firewall or for security appliance, right? And then it will work as one module. So you have other modules, maybe for routing, other modules for other things, maybe other services like DNS service or whatever. So many services are there. Everything is packed inside the operating system, and operating system has a right to give instruction to all these services. So what I'm telling, let me quickly show you within this slide. I have slide related to this, so you will understand. Let me quickly go and show you this, what I'm telling. So now you will see that this is the movement of the packet, not this one. If I have one slide, yeah, I was actually looking for this slide. Now you can see. So now you will see here that how the architecture for the firewall built in. So you can see that you have data plane, and same type of architecture we have for firepower or any type of advanced firewalls. Same thing is happening. Now here you can see that we have the daemon. Small d stands for daemon. Daemon for operating system, IOSD. And then you can see everything is hosted over Linux operating system. So we can go and make containers. It's like container services, some sort of hypervisor you can think. Then you have something called LXC container. Over that you have IPS module. This is a Snort engine used for IPS IDS services, right? And here somewhere you will find that you have firewall module as well. It's very interesting. Actually, firewall modules generally they are part of data plane. So what is happening that suppose if you are providing the policy, applying the policy, normal firewalling policy, normal ACL policy, so traffic will go normally in this. This is the traffic path, the data plane. But suppose if you go and use advanced malware protection, URL filtering, Snort engines and all, then the traffic will go up vertical. Some rules will be applied here to that traffic. After the application of rules, it will come to the data path and then it will go outside. So doing this, obviously there is process and CPU utilization, and that's why we know one thing, that since we are using some container applications to install these services, they are not native like. So someone can ask you, okay, tell me the difference between normal Palo Alto and this type of firewall. Normal Palo Alto, their hardware is built for all these applications, all these filterings and all. This type of arrangement that we have normal operating system, but parallelly we are installing some virtual image, and then we are putting all the codes related to firewall and IPS and IDS and all. Obviously, it is not integrated service, so that's why there may be lag related to this security application. There may be high CPU and memory utilization. That's the one thing. What is the advantage then? The advantage is this, that cost cutting. You can cut the cost, right? Because the same device is using for all the things like routing and the VPN and all the services. Everything is provided by the same device. Now let's quickly go and see the container architecture. This is actually some of the terms you will see that it is used inside the TAC world. It's actually not for us. Just for knowing this architecture, I'm going to show you different terms you're seeing here. Actually, these are the code names. So you can see here TG. Oops. Code names are there that generally Cisco tags are using these code names and all. So Beaker, TG, something, Snort. So Snort has so many other services which is glued. Then you can see there's data acquisition queue. That means the data plane request will come to the queue. Obviously, everything will be queued and it will be processed as per the request. So you have this data acquisition queue, then you can see the virtual path. Request is going to the Snort. In Snort also you have different things, different policies. According to that, it will reply, and then again the packet, finally packet has to move. Finally packet has to move within the data path. Right. Now you will see clearly in this diagram that you have the operating system, but the main operating system is here, iOS daemon. And now you have the container where you are putting the virtual images to do all the processing. So we have intercommunication in between the iOS daemon and the container. And then you can see this virtual app nav infra. This is again one program which is integrating the iOS daemon and the container services. Right. These are the arrangements by which the secure services we are providing in the Cisco devices. Now you can see here that do we have any hardware requirement to run these services? Which type of devices supporting what type of services? Yeah, that is right. And you can see here in the list that if you want all sort of features, which platform is supporting what type of feature, and this platform how much boot flash and RAM required, how much core of CPU required. Then you will see if we have on-box lookup, it can be provided with 4331, 4351, these hardware or these routers. There they have, this is the minimum requirement. Minimum 16 GB of boot flash, 16 GB of memory. You can see this is minimum to run all the services like IPS, URL filtering, AMP, threat detection, is etc. Right? So be very careful when you are using the firewall services in the enterprise, how much firewalling we need according to that requirement. We have to go and select the hardware. Right? Again, these are some of the slides for reference. And this is the walkthrough related to security. Obviously, we'll go and learn more about this security, means configuration related things in the upcoming session. So from next class onwards, we have to go and follow the lab guide. 700-page lab guide we have that we are going to follow. All right, if you have any question, please feel free to ask.